Hello everyone, welcome to Coding Autos. Today we will solve one of the lead code questions, which is threesome. So what it says is we need to find a triplet which when added gives a sum of 0. Okay, this when added gives sum as 0, and they are saying that duplicates are not allowed, duplicate triplets are not allowed. Okay, so let's see an example. If this array is given to us, this should be our output. This is one of the triplet and this is the second triplet. When we add these, we are getting answer 0. When we add these, we are getting sum as 0. Okay, so that's why these two triplets are returned. And if you observe, we don't return any repetitive triplets. Okay, the triplet should be unique. Here, if we sum them, we will not get a sum as 0. So we are returning nothing. Here, if we add them, we are getting 0, so we are returning this. Okay, so now let's see how to solve it. First of all, let's see a brute force approach. Okay, so an array like this will be given to us. So brute force approach is we will take three pointers, we will take three for loops or any loop, and it will be nested. Okay, the first pointer I will point to the outer loop. The second pointer uh, will have search space from here to here, and the next one will have search space from here to here. Okay, we will increment I, increment j, and increment k accordingly. First, when I is over here, j will have a range to go from uh, here to here, and k will have a range to grow from 1 to -4. Okay, so we will first of all fix 1 and 0, then k will move from here to the end, and it will check whether we are getting the required sum or not. Then j will be incremented to this, and k will start from 2 to -4. Okay, now -1 1 are fixed, and it will be added with 2, -1 -4. If in case we get the required sum, we will return the triplet, and this will go on continuing like this. Okay, then after j has finished, now I will be incremented. I will be pointing to 0, j will point to 1, k will point to 2. K will move from 2 to -4. Okay, after this iteration is over, now j will be incremented. I will remain there itself, j will be incremented, k will move from -1 to -4. So hope you understood. Let's see it in coding. So as I need to return a vector of vectors, so I'm storing my answer into vector of vector. Okay, so I'm making an answer variable and I'm storing it. Okay, so this is the outer loop which I will be traversing. So as you can see, I will traverse from the starting index to the uh, uh, third last index. Num size -2 means the third last index, because we want uh, two elements in front of it, right? We want a triplet. If the outer element is itself less than 3, how can the rest of the two elements, how can we get triplet? So at least as we want triplet, this outer loop should run up till the third last element. Okay, uh, okay, and the inner loop, as I said, it will run from I plus 1 to the ending index. Okay, um, or we can say second last index. Okay, this will run up till second last index, and this third nested loop will run from j plus 1 till the last index. Okay, now all the elements which we have, num is an array, nums is an array, so num of I, nums of j, nums of k. If after adding all these, if we get sum as 0, then this is the triplet which we wanted. So we will make a vector called as triplet, and push those particular elements in that triplet. Okay, we can write this into one single statement also. push back nums I comma nums j comma num k, but let it be like this. Okay, after pushing those elements into the triplet, we need to sort it. Now, why are we sorting it? We are sorting it because we need to further check whether these particular triplet is present in the array or not, and it would be difficult if the triplet is not sorted. Yeah, so that's why we are sorting it. So next time if the same triplet appears, it would be easy to check and then figure out whether this should be included or not. Okay, so we have pushed the triplet. Um, we have pushed the element into the triplet. Now find. Okay, this I have explained what find will do. Yeah. Once we have inserted the elements into a triplet, I need to check whether those elements of the triplet are matching the already present element into our set. So I have made a set called, I have named it as check. So this will contain all the unique triplets in it. Okay, so I am checking it over here that if I will check whether this particular triplet which I have made over here, whether this is already present in the set or not. Okay, so find means find will return the particular index where this triplet is present, and it will return the index. If that particular triplet is not present, it will return the index next to the last index, and end will anyways return the index next to the last index. Okay, so if the element is not found, this condition will get true, and we can push that particular triplet into our answer vector. Okay, after verifying that this particular triplet is unique and we have not gotten it yet, we can push this particular triplet into our answer vector, and then we can also put this into our set, so that if in case we get the same triplet again, we can check this particular condition, and then if this particular condition will be false because we already have the triplet, so it will be not pushed into the answer vector and also into the um, set. Okay, so this is the condition which we will be using to check whether that particular triplet is already present in the set or not. So by doing this, we will get all the unique triplets into our answer vector, and once we come out of the for loop, we will simply return the answer. Okay, so this is the brute force method. Now let's run it and see whether it's running or not. Anyways, I've already run it. Let's see once again. Okay, all the test cases are passed. Let's submit it. This will give an error, runtime error, TLE. Okay, because its time complexity, as you can see, is big O of n cube. As we are using three nested loops, the time complexity would be order of 3. Okay, so this is not a good way to solve. uh, if in case in any of the interviews they ask you to give me a brute force method, you can give this method to him. Okay, but it will not be accepted over here. Okay, so let's comment it out and let's see the optimized approach. Okay, I'll uncomment it. Let's see this approach. This approach takes time complexity of big O of n square, and we will be using two pointer approach to solve this question. Okay, now as we have to find unique triplets which would sum to 0, what we can do is we can fix a number, whatever the we will take two loops, outer loop and the inner loop, and the outer loop will run from 0th index to the third last index. As I said, as we need a triplet, the outer index should run maximum up to the third last index only. Then I'll take a inner loop which would now I'll not take two nested loops, I'll just take one nested loop, and I'll take two pointers. The first pointer j will point to the element the uh, next to the pointer I. Okay, so initially j will point to I plus 1 and the next pointer will point to the last element of the array. Okay, and this loop will run the until j is less than the last pointer. This is the j is the pointer after I and h is the pointer which is at the end. Okay, so what we will do, we will first of all we will sort the numbers. Okay, nums is an array, we will sort it. Okay, so after sorting it, all the elements would be in ascending order. So we will see whether the and we will again increment our sum. The sum which we want is 0, but whenever we will calculate the sum, we will just calculate the sum from array of j plus array of h. Okay, and that sum should be equal to our given sum minus our minus the element which is present in I. Okay, minus the element which is present in I, because that element we are not considering. So our current sum should be equal to 0 because 0 is what we want. So from 0, if we subtract the element which is present at the ith index, we will get our current sum. And if we want 0, you can see that current sum would be array of j plus array of h. Okay, and if we add sorry, nums of j plus nums of h, and if we move this nums of I to the left hand side, we can get 0. So we are just manipulating this formula and we are calculating the current sum. So and after that we are placing j to its position after I, one position after I, and j should be pointing to the last position of the array. Okay, now we are running this loop until j is less than h. So what we will do, we will compare the elements on those particular index. So we will add those index and see whether it is greater than the current sum, less than the current sum, or equal to the current sum. Okay, so if we add those two numbers and if the addition is greater than the current sum, so what does this mean? This means that the first index, it is greater. So as this is greater than the current sum, which means that we need to lower the sum. So how will we lower it? We'll lower it only when h is decremented. Okay, so the number small, where will the smaller number be present? From starting from j and going forward, the numbers will be in increasing order, but starting from h and coming backwards, the number will be in decreasing order. And now we want that this sum should come equal to the current sum. Now it is greater and we want it to come equal to the current sum, so we will decrement h so that we would get a lesser number. So after decrementing this, we are now we are decrementing it. Okay, so after decrementing it again, mm, this loop will run. um, Now suppose we have decremented it. Okay, after decrementing it, this will be skipped, this will be skipped. Now again a next loop will run. Next loop is running, h has already been decremented. Now again it will check the sum. Again if this is greater, again h will be decremented. It will keep on decrementing until this is greater than the current sum. Okay, now in case if we got an sum of these two elements which is less than the current sum, then we will, then what we can do, as it is less, now we want a greater number, so we will achieve a greater number only when we increment j, because a greater number is present at the next index of the j. Okay, and always moves to the right hand side and h always move to the left hand side according to our algorithm. So when we move j forward, there are chances that we would get we would get sum equal to current sum. Okay, so that's why we are incrementing j. or if it is not greater, if it is not less, it is equal. Okay, sum of these two number is equal to the current sum. That is the else case. And if it is equal, we have got a triplet. Okay, we got a triplet. So we are making a temporary vector and pushing those particular elements into it. I am pushing those elements into temp vector, and then I need to check whether this particular triplet is already present in the set or not. Okay, so um, I have set a vector called as present. So I'll first check whether these triplet is present into the set or not. So if it is present, this particular condition will not be executed, and if it is not present, then we will push that particular this triplet into the answer vector, and then increment and also reflect it into our set. Okay, and if this particular element is present in the set, we will not do anything because we don't want duplicates to be into our answer vector. We'll do nothing. Now, once we have got the elements which would add up to give the required sum, now what we will be doing? So think about it, that those elements at which we got the our required sum. Now what we should do? We should increment j or decrement h. So if we increment j, and if the next element is also same to the previous element, then we would get the repetitive triplets. Okay, and if we decrement h, and if the previous element is same as the current element, then also the triplet would be same. So what we will be doing is, we would check whether the j plus 1th element and jth element is equal or not. Okay, so currently j would be pointing to something. After incrementing or decrementing, j would point to something, h would point to something. So we would check that when we increment j, is are those two elements same or not. If they are same, it is no need to again find out triplets, because they would be anyway same. So we need to skip all those elements which are same. So that is what we are doing. If the element next to it are same, we are just incrementing j. We are incrementing j until the next elements are same. And while doing this, as we are checking j plus 1th element, next element to j, we need to also take care that j should not exceed h. Okay, it should not exceed h, or it should not exceed um, the array size. Okay, so we will get a segmentation fault. So if we take care of this, there will be no segmentation fault. So before writing this statement, we should write this statement. Okay, so we should keep on incrementing j until this condition is satisfied. Once we get once this number is not equal to this number, we will come out of the loop. Now while come out of the loop, we are currently on the same index, which was same element which was continuously repeating. Okay, so we will increment j by 1, so that we are currently on the new element and not the repetitive element. So we are incrementing j once more after coming out of the loop. Now let's see this while loop. It is similar to the previous one, just we are decrementing h by 1 until we are getting same elements. Once we stop getting same elements, we will come out, and as the h is currently pointing to the same element, we will again decrement it so that we will get a new element. Okay, so after coming out of these two while loops, both r, j and h will be pointing to the unique elements. Okay, as it will point to the unique elements. uh, Now um, again this loop will be checked, else condition is satisfied. This is our loop which was executing, and it will end over here. Okay, now r1 was already fixed over here. Okay, and we were incrementing j from here and decrementing h from here. Okay, and we are keep on decrementing it until j is less than h. Okay, until j is less than h, we are keep on doing it. Once j is equal to h or greater than h, we will come out of the loop. Here we are coming out of the loop, and now we need to see this also, that whether our um, whether when we will increment I, okay, so there are chances that I would also repeat, right? There are chances that I would also repeat itself. So we need to skip all those I where the elements are same. Okay, so initially if after sorting we got two ones, so we have already seen what are the possible solution triplets for when I is equal to 1, and we are iterating j and h accordingly. So as we have already done for 1, we should not consider it to be doing for 1 again. So we should skip all the i's, all the indexes which have same element. So for them also, until nums of I is equal to nums of I plus 1, I am skipping it, I am incrementing I by 1. Okay, and as I am checking the further element, I should also keep a track that it should not exceed the array length. Okay, so here I am keeping the track of it also, or else it would lead to segmentation fault. So I'm incrementing the I will be doing it until I don't get a unique element. Once I plus 1 is unique, I'll stop over here. I'll not increment it, because once next loop will run, once this will get incremented, it would already point to the unique element. Okay, now the next iteration is running. Again, in the next iteration, current sum would be counted. It would be 0 minus the current element into which the nums is pointing. Then j would be next element to I, h would be the last element, and this will keep on continuing. So in this way this code would be running. Now if you would see, there are only two for loops running over here. That is why the time complexity would be big O of n square, and we have significantly reduced the time over here. Yeah, here it was taking big O of n cube, here it is taking big O of n square. So it is a good approach. And sorting, as we are sorting over here, we are using predefined function. So predefined functions are already optimized, and it would take n log n time, which is lesser than n square, so no need to worry about it. Mm. So the time complexity at the end would be big O of n square only. So I hope you understood this code, both the approaches you should understand, and only when you understand both the approaches you would be able to figure out which is the best approach, and you will get uh, only when you know all the approaches, it's easy for your mind to think different solutions in for the different questions. So you should try many approaches. In the when you submit your code, you would be able to see all the hints or codes submitted by different people, so you can see that also. For now I will be giving this code to you. I will be giving my GitHub link, so then this code, same code, I will copy paste over there, so you can have a look into it. Also I'll give link to this lead code question. You can solve this question over here and submit it. Okay, so now let's run this code and see whether now it is running or not, or still it is giving TLE. Let's see it. Hmm, it is accepted. Let's submit it. It should run. Yeah, it's running and it is accepted. Okay, so that's it for today. Let us meet in next coming video. Thanks for watching, and bye bye.